I'm forever blowing bubbles, little bubbles in the air. Hi, my name's Bob Greenyer, and I'm a volunteer with the Martin Fleischmann Memorial Project. So welcome to O-Day Blowing Bubbles. How is everyone? This 13th of August 2023. Okay, excellent. Hi, Stephen B. Halls, Tony Giamoni. Hi, Space Case Daniel Foster, Starfish Troopers, D2105K, Tucker Point Dexter. Hello to Corky Goss is in the house, Duke Tree 64. Hi to one and all. Kevin Smith, hello. Thank you for joining us. Thank you to join us. Join the technicians. Sorry for the delay here. The joy of Windows. So what you're looking at on the screen there is not, in fact, a light bulb. It's something far more interesting, although it is emitting light. So as you can see, I still haven't shaved. I have my filming on Tuesday around lunchtime. It's about the birth of surgery. And I will be playing one of the world's first surgeons. There we go. I'm not a doctor, and I will not be a doctor there either. So I didn't get to on the SEM in the last week or so. However, the part that was missing, the tray for the SEM, has made it through customs, and it is now with the company, the distributor, and hopefully on Wednesday I will be able to look at various samples, including the Henk-Uren Vega map of the pyramid, the cardioid infarction. So I'm going to be very excitable when I put that under the SEM to see what is down in that disruption zone at the bottom. And we have some other very interesting samples. Now, ICCF 25 is coming up in Szczecin in Poland. And I had the great honor of one Bin Jun Huang contacting me earlier this week and requesting if I would be so kind as to consider being a co-author on his paper for this year's presentation. Well, that is very generous of him. It stems from a prediction I made a couple of years ago based on my understanding from 2019 and the MFMP Parkhomov reaction tables programmed by Philip Power in New Zealand. And I predicted that he would see carbon synthesized, a bit of phosphorus, a bit of sulfur, probably some silicon, but that he would see some neon. Now, in that presentation, I was a bit tired as usual and trying to fit too much in. And I predicted that more likely, because I was reading from the bottom of the table, I wasn't even following my own logic, that he might see neon 21. Well, in fact, he didn't see neon 21 or 20, he saw neon 22, which actually follows my logic of it being the most energetic yield product in the form of neon, and that is good because he found the one my theory should have predicted, but I gave him the wrong thing to search for first, which was just neon in general, but probably neon 21 first. So actually it turned out quite peachy. Now, the jury's completely still out, but if this is true, then we have a gas that can't possibly be a contamination. One could always say that silicon and phosphorus, because phosphorus is sometimes used on the inside of copper pipes in the form to prevent corrosion. It's maybe coated on the inside of water pipes. He says that's not the case. It doesn't have that process on it. And sulfur, we know, comes from the fusion of oxygen and oxygen, so that's to be expected. We saw that on snowballs on cobblestones, where, if you recall, in the Amasa gas, the split oxyhydrogen gas on a 10 yen coin, we had a substructure of the overall toroidal structure off to one side, a sort of monopole, and on one side it had what appears to be zinc, and on the other side it has nearly pure copper with oxide layer on the top, with 4.1% roughly of zinc, and that is in my view is all of the spin isotopes, because you have copper 63, copper 65, both spin isotopes, and then you have zinc 67, and that's why we see that on one side. And there were these little plasmoids or microball lightning, or these itonic clusters or exotic vacuum objects. Let's say they were the same as Bogdanovich's plasmoids running around on the surface for 2 days. It would appear that they were consuming the oxygen and fusing that to sulfur in those little snowball trails. And so it's not surprising we see sulfur. But again, it could be a contamination. But what doesn't look like it's a contamination, and they've done some excellent work over the last 2 years, it looks like it's neon specifically 22, which is the reaction product most favored of the neon gases from oxygen 17. So we'll have a quick look at some of that. The paper will be published at some time, probably as a preprint in the next week or so. We're still going through it and correcting errors. And then the presentation, which will only be 20 minutes at ICCF, my presentation will likely refer to his work and some work that's being done by the Engate team in Portugal and in the south of England and so forth. This plasma reactor as a potential direct energy generator. I believe these are all working on the same phenomena. And the title slide here actually comes from a paper, and I'll tell you how I came to find that paper. But first off, I am going to pull up a paper, a patent that I shared with Binjuan Huang in the process of discussing his work for ICCF 25. And if you go back to the my Azizi presentation from last year, I referred to the work of one Kladov. And Kladov was doing heat generation cavitation reactions in the 1980s, and he built on that work to secure 2 patents, 205.4604 and 208.5273 in the Russian Federation, and he claimed that he was producing thermal energy between 2 and 7 times. And I think the maximum that they've achieved in the University of Taipei or Taipei Engineering Department there is I think 4.46, which is smack in the middle of this. I have many ideas for improving the process and getting that energy up, but of course you need to not have the device fail in the process. Anyway, at this time there was a bit of ridicule by the Russian community, and in this later work by Kladov from 1997 to 2002, he says the purpose of this work is to demonstrate the real possibility of cavitation destruction of matter on the example of transmutation of various chemical elements, showing at least 3 main modes of destruction: changing the structure of a nuclide by adding 1 or more structural elements, changing the structure of a nuclide by dividing it into several fragments, or changing the structure of the nuclide by dividing it into the smallest structural fragments, or by the complete transformation of the matter into radiation, into field forms of the existence of matter. These basic processes of cavitation, destruction of matter, occur in the ultrasonic activator almost simultaneously. So building elements, breaking up elements, so making, breaking, and complete annihilation, but with varying degrees of intensity. So the device that I showed was this, and you have a device for doing the ultrasonic actuation here, and water going in and everything. And he found also in this work that in a period of time, they were able to remediate 137 cesium to 65.1% decrease in the emissions per second, I guess, or per minute or whatever. So there we go. And in terms of element synthesis, in 2 hours, they were seeing 19 elements produced. In 8 hours, 23, 24 hours, 29 elements, and in 360 hours, they were producing 55 elements. Now, they were producing predominantly magic numbers of nucleons, and this would mean they are bosonic nuclei, and so a proportion of those were twice magic, like calcium, which is 2020, or something like, let's say, what else? 1010, is that neon? Maybe. Anyway, together, all magic elements represent 41%. And then in this work, he said he discusses the presence of supermicroscopic black holes and a detector for their output of super short wave electromagnetic radiation and resultant data consistent with their presence during cavitation. And this wasn't verified until it was done in the hydrowave technology, these devices in 2006 and 2009 respectively, and they also saw a different beta isotope lose its radioactivity by the process of cavitation. Now, there is an updated patent, not by him but by another party, and it is the patent that I shared with Benjamin Huang, and here it is. It is RU2422733C1, and it is a heat cavitation generator, and you can see that it has holes in it and centrifugal kind of veins in it, and it can be in a multi-stage with a single axis, and it's well described in here. One aspect of it is these conical tube basic holes in here, and this increases pressure and then decreases pressure as it goes through these various holes, and that is a key to doing cavitation. And it's similar to the presentation that I showed of the vortex heat generators, which were shown to produce a COP of up to 1.5. And in here you've got a conical constriction and then a destriction here, and the water flow is going this way. You have these rarefaction pulses, and when two rarefaction pulses collide, they produce a soliton, and the soliton is then effectively compressed and then decompressed, producing a cavitation structure. And then because it's in the center of the flow here, because of the way the dynamics of the rarefaction pulses come into the center of the channel, you don't get the typical damage that you get from cavitation on the side wall. So the cavitation happens in this zone, creating the heat. So interestingly, they have this re-entrant jet here, but you should probably not have a re-entrant jet if it's in the center of the channel in the same way, unless maybe you've got a couple of these bubbles colliding, and we're going to see something similar to that. So yeah, this is the hydrowave type technology that I was talking about. Okay, so in this patent here, it actually has a reference to this work by Kladoff, and it says that this patent is actually the closest to the work of Kladoff. So let me just find that for you. So it says here, if I go to the right point, closest to its technical solution to the claimed invention, the patent of the Russian Federation number 2054606 method for producing energy by Kladov, which was actually published, it was applied for in 1993. So this is after the Cold War. A lot of things were patented after that from research that was done under the Soviet period. And it was published in 1996, in which the process of increasing heat in the proposed cavitation unit, I'm going to try and zoom into this a little so that maybe you have a chance of seeing it, with the effect on the pumped substance with variable and constant pressure. Now, he talks about where there's problems in this, but here is the key part here. According to the above description, in patent number 2054604, cavitation bubbles form during the action of a half period of negative half-wave alternating pressure on the liquid in the treatment zone. During the action on the liquid of the next half cycle of the positive half-wave of alternating pressure, the cavitation bubbles are compressed. By the end of this half cycle, the bubbles store kinematic energy, which is determined by the pressure difference acting on the bubbles from the outside and from the inside. Outside, the sum of the alternating and static pressures acts on the bubbles. Inside the bubbles, the pressure of the saturated vapor of the liquid acts. In addition, other forces determine the physiochemical processes of the liquid, as well as the absolute values of the claimed output parameters also influence the movement of the bubbles. At the moment of collapse of the bubbles, the kinetic energy is converted into the energy of collision of elementary particles, according to the description of this patent, the one they're referring to, of Kladov. The energy released during the collapse of the bubbles is several orders of magnitude higher than the binding energy of elementary particles, nucleons, in the nucleus. As a result of a collision of nuclei in the conditions of the proposed method, an interaction occurs between the elementary particles that make up the nucleus. The energy released in the reactions controlled by the described method between elementary particles is converted into thermal energy in a liquid, and it is removed from the treatment zone with a flow of working substance. Okay, so that is what they are claiming in this patent, which is building on the work of Kladov, which is building on these vortex heat generators, and this is from... The application was granted, here you can see, here on the 27th of 6, 2011. Now down the bottom, it actually has the fact that on the 20th of the 12th, 2013, the patent is now invalid due to non-payment of fees, and that was effective from the 17th of the 2nd, 2013. So this is non-valid. I don't know whether it can be validated by effectively paying the fees, but that is a patent that refers to cavitation leading to the transmutation in the Kladov work. Now, I couldn't find the Kladov patent, to be honest, and I challenge you guys out there to find it. Maybe you can go to some Russian portal to find it. But seeing as this patent argued that it said this, then it's not so important for me for the purpose of discussing this with you this evening. So there's an aspect to the toroidal moment and to this overall structure that I've been wanting to talk about for a while, and it's necessary to talk about it now. And it essentially comes from this particular image here. And this particular image was used by Leclerc, and when I was defending one John Hutchison from Robert Murray Smith's attack, a US naval nuclear scientist came and defended Robert Murray Smith, and this is an attack dog for naval intelligence as far as I can work out, and nuclear regulation. Anyway, that was on remote view. I don't know whether those comments have been deleted, but anyway, this bubble started to look a little bit like what we have seen in our overall research, and I wanted to explore that concept. And this is a photo taken by one Lawrence Crum from the University of Washington, where, you know, that I do know there's at least one naval researcher working. And you can see he's a bit of an expert in ultrasonics. There's many articles there. You can go and look it up. One of those is this sonoluminescence and bubble dynamics for single stable cavitation bubble here at 21 to 25 kilohertz. And he talks about sonoluminescence, this thing that has been known for a very long time. And there is an interview here with Crum about his work. And again, this photo appears here. So what I did was, and this was some moons ago, but it's, like I say, it's appropriate to start talking about it here now, is I took our usual sort of PDF, our Photoshop file here, and I overlaid the sacred geometry. And all I've done to the Crum photo that you can see here is I've just turned it upside down. And that's just so I don't have to turn the geometry upside down, our sacred geometry. Okay. Now, this is a reentrant jet coming in to a hard surface from the water body. Okay. And when I'm looking at this, I am seeing this. Okay. And so we have this collapse to the central area. So if you remember, this central area here is where you have not that one, this one. So like you actually have the vortex in this central area. It's not affecting this bit of material out here. So this is where the incredible vortex is. And we know that from many different experiments. So if I line that up, this is what we get here. So the main vortex is here, rather, and we have this flat area here, and the collapse goes through the center and produces our re-entrant jet here. Now, I call this the mean square radius, this structure here. How do we derive that? Well, just to remind people how we derive that, and it was all from experiment process. Firstly, we started with Neil Crichton Gould's Lion 1 reactor, and on there I found very many important features, and one of them was this, what I call a bar spiral galaxy, a 2-arm bar spiral galaxy. We also found a 3, we found a 5, 4, a 2, 3, 4, and 5. On the outside crust, we found a 2 and a 3, and on the inside, we found a 4 and a 5 structure. Okay. Now, the interesting thing that I saw when I saw this was these two holes in the center that kind of like went at an angle that kind of seemed to roughly line up to where these things came out. What are these things coming out? I had no idea. And there seemed to be this circle radius where there was nothing affected in there. So how does this occur? Well, over a period of time, we saw different things. So this one I talked about, this bubble structure here, again, also in my presentations about the Ultra experiment last year. And if I bring that up now, that bubble structure is just a mirrored version of this by Metin R. Bubble structures in acoustic cavitation from Universität Göttingen in Germany. And so this is the bubble structure, and I suppose that this is what you might see in the center of these structures, and then these form a pair, and then these form a pair. Okay, so you're sort of seeing the fractal structure there. And the other thing that I want to refresh your mind against, is this sound field with this standing wave with these two structures here, with something linking them. So when I play this, you can see how the standing waves, there's a vortex into these central things, and you like have one bright white spot and one kind of like a black spot. But there's kind of like a pair of spots here, and then there's something that's joining between them. Okay, so in those instances, if you hold those in your mind as we go forward. Okay, so this here is the main structure of that work that I just showed you. And if we overlay that onto the lion, we have the beam coming out here and the beam coming out here. Okay? And it seems a bit weird that it's in the center there, but that's the only way that this can possibly line up. Now, in work of cavitation in Japan with Dr. Roshin Amaza, this structure here, which I guess is about 10 microns across, this one's actually bigger, but it was a lower resolution microscope. I think it, no, this is 5 microns from there to there. This is 10 microns. Okay, well, I flipped that and rotated it to line up to other work, and if I zoom in, you can see that if we overlay the 2 points here with the lines coming out with our structure here, then we end up with a composite shot where this bit that's unaffected in the center of this original structure back here, and it's flipped like I say, it is outside this hemispherical cavity. Now if we zoom in, I've overlaid the bubble structure here in the center, and you can see the lines coming out here, and there's this structure here. Okay, so that led to this typical spiral that you get, and this is based on the 2x4 in the center of the Great Pyramid. Again, like 2x4, or like that's the ratio of the King's Chamber. And in the dead center, you have just 4 units, and I would argue at the smallest level, these 4 units are the Planck's distance. So it's the minimum structure you can have in the center there. And if you follow that out, you get to this point where you kind of have an ejection and you have an ejection. And if you go further out and again go round, it ends up cutting through here and cutting through here. So you have a thing that easily allows you to understand what's going on. And if you overlay the bar spiral galaxy from the James Webb Telescope as is, you can see that the bubble structure lines up. The sun, or the bright spot in the middle there, lines up. It is this oblong type shape here, as we see from the geometry that you have here. And these are things that are known and talked about, but it's the coherence between these things at multiple scales. Okay, so that is the overall structure that you see. And this led me to believe that this actual circle was very, very important. And ultimately, when I overlaid the 3D structure that I'd already built of the fractal toroidal thing and this sphere, which is defined by the bottom of well, the radius of the Sothic triangle, or rather the bottom of the 3 spheres below, you ended up with this event horizon area here. Now, the bits where the stuff bleed out is where the disruption zone interacts with the outside event horizon of the tier above. So it gets to here, but it's slightly in because this is distorted when you only have 2. It goes into this more block shape. And so that is how I defined this sphere radius here. Okay. All right. That being said, I'm going to show you another paper here and how I came about that. Well, Charles knew that I'd been asked earlier in the week to be an author on Binzhen Huang's paper, and so I guess he got inspired to look at different effects that are going on, and he sent me something about what's called bubble jet effect with respect to naval mines. Okay, so we're back in the Navy here, and So this is effectively a Wikipedia article on naval mines. And down here, there's an aspect of this called the bubble jet effect. And it says here, the bubble jet effect. The bubble jet effect occurs when a mine or torpedo detonates in the water a short distance away from the targeted ship. The explosion creates a bubble in the water, and due to the difference in pressure, the bubble will collapse from the bottom. The bubble is buoyant, and so it rises towards the surface. If the bubble reaches the surface as it collapses, it can create a pillar of water that can go over 100 meters into the air, a columnar plume. If conditions are right and the bubble collapses onto the ship's hull, the damage to the ship can be extremely serious. The collapsing bubble forms a high-energy jet similar to a shaped charge that can break a meter-wide hole straight through the ship, flooding one or more compartments, and is capable of breaking smaller ships apart. The crew in the areas hit by the pillar are usually killed instantly. Other damage is usually limited. Now, it's interesting because this is the Navy. It's very important to the Navy. And when there was Graham Hubler criticised an exotic vacuum object as being nothing more than shaped charge, and that's, or rather, the way that it burrows through material is nothing more than how a shaped charge does it. And he made this argument, although and this was his ICCF 24 presentation. He made the error of not being aware, potentially, or being aware but not talking about it, the Usharenko effect, where you have a shaped charge, even a plastic, with a aluminium and ammonium nitrate explosive, and then you have the same shaped charge, but you replace the area where you put the copper with sand, and some of the sand bounces off the target steel, but other particles of the sand burrow up to 30 centimeters into the solid steel, producing a hollow channel which on its periphery has transmuted elements. So I think it was a foolish thing to try and spread certain views using shaped charge, but it's interesting that the naval former Naval Labs researcher would use this analogy given what is discussed here. Now, the thing is, when you have an explosion of a mine, it will produce a plasma. And we know that in many circumstances, plasmas like to self-organize, don't they? Well, there was another person that was the cause of the naval intelligence guy, nuclear guy, trying to rubbish me after I tried to defend John Hutchison on Robert Murray Smith's site. Basically, he was stepping in to talk about that and saying that another person that I mentioned in defense of the fact you can have transmutation was one Leclerc. And basically, he said Leclerc's stuff was nonsense, okay? And that's very interesting because you've got a naval guy saying that Leclerc's stuff was nonsense. And so let's go and have a look at what Leclerc did. And I have a presentation of his here somewhere. And I've probably put this on a slow drive, so this might be interesting. Okay, so this is Nanospire, and this is a presentation from 2012. I've referred to it before. You can see that he's got the LA Crumb photo here. And this is Leclerc himself, Mark Leclerc. So this was the guy that, whilst trying to support Robert Murray Smith's attack on John Hutchison and Lenner, this guy who's naval intelligence, nuclear research, safety guy, came to defend the attack out of the blue onto my blog, and he particularly chose Leclerc to attack as well. Leclerc shows that he uses a laser to produce a vaporization of the liquid. One might imagine that that's because of the energy concentration. You also get a plasma. So here you have two instances where you have an explosion in a mine, sea mine and you have an explosion in a cavitation produced by laser. Of course, laser will also produce coherence and things like that. And so you have the fully formed bubble here, which is this size. And when you start to get down to cavitation, reentrant jets, it shrinks. So when I am lining up my object here, if I can find it, this one here, I'm thinking that this is the stage that Leclerc is referring to, not here. Oh dear, this is going to be painful. That he is referring to kind of like here, where it's quite a lot smaller. Okay, this fourth section down. Okay, this is the fourth section down. So the actual bubble was quite a lot larger. So I thought, you know, is there the chance that the maximum size of the bubble, based on the vortical structure in the center, which would be a plasma in the case of an exploding mine, and would be a plasma in the case of maybe a sonofusion event, or would be a plasma in the case of this laser thing, would the full bubble size actually be out here? And I had been searching and searching for research or an opportunity to do the research myself that would give me a clue as to whether actually, in fact, it was this kind of mean square radius distance away from the structure in the center, which would effectively support this structure, okay, except I'm looking at it from the side here and I'm looking at it from the top here, okay? So, just as an interlude, I will show this quick clip here of what a detonating mine looks like. So that is on Mine Clearance Divers Demolish Naval Mines. Now this is actually a triggered mine, but you can see the kind of water spike, and you can imagine you wouldn't want to really be under that when it goes off. Okay, I think we can safely say that. So that's the bubble effect. And so when I was replying to Charles, I came across a paper, and it was basically on the term water spike. And I came across this paper, and I think we're going to look at it today because I think it is very, very important paper with regard to explaining certain things that we may have observed. Okay. So it's called Experiments on Bubble Dynamics Between Free Surface and Rigid Wall. Okay? Free surface and rigid wall. Now, remember in our ultra experiments, we kind of basically have a rigid thing at the bottom, a flexible aluminium foil suspended between water above and below, and then another semi-rigid wall, in this case polycarbonate, above. And that may be why it is so ridiculously repeatable. But before we get into the meat of this, I just want to show you who supports the funding of this research here. This work was supported by the Project of Outstanding Youth Fund of China and the National Security Major Fundamental Research Program of China. The National Security Major Fundamental Research Program of China. The authors are also grateful for precious advice and support from Dr. QX Wang from University of Birmingham. Okay, so I am pretty sure that all of the learning from this paper is also relevant to naval sea mines. Okay, now, experiments on the bubble dynamics between free surface and rigid wall. Okay. Experiments were conducted where the underwater bubble oscillates between two boundaries, a free surface and a horizontal rigid wall. Without the solid wall, then the other boundary was inserted at different positions to observe the changes in the motion features, including the types, maximum speed and height of the water spike and the skirt. the form and speed of the jets, and bubble shapes. Now, we already talked about this kind of thing, where there isn't cavitation, but there is rarefaction pulses leading to solenoid, toroidal vortices in the water, and then when they hit they build up a lot of vorticity and energy, and when they break through the surface, they can actually eject water. And relatively speaking, this is ejecting water far, far higher than what we saw scale for scale in that explosion. Okay, so and we went to a lot of work. The other thing to hold in mind is that when the sound is turned off, we literally see a toroidal bubble. Okay, and that is exactly in the in this case, this is the pit with the cone, and it peels off and forms a spherical bubble as it moves away from the place in which it was born. Okay, so that to the side. Intriguing details such as a gas torus around the jet, double jets, bubble entrapment, and microjet of the water spike, etc. are observed. The interest in bubble interactions with boundaries mainly arose from the damage effect to nearly all known surfaces, such as ship propellers, turbines, and other fluid machinery. Spherical bubble collapse in infinite free fluid field can be roughly modelled by the Rayleigh-Plesset equations from 1917. On the other hand, the collapse of bubbles near boundaries will be asymmetrical, with the formation of liquid jet in suitable conditions. The physical property of the boundary is crucial to bubble collapse, especially the direction of bubble jet, in which the bubble migrates and produces a jet away from the boundary and becomes toroidal. Most of the simulations were focused on the collapse phase before jet penetration, while Pearson in 2004, Wang in 1996, etc., obtained the subsequent toroidal bubble, and the simulation stopped before the bubble rebound. In the current work, more detailed observations are made to the late collapse phase of the bubble, including a second toroidal bubble rebounds, as well as the scenario where two jets were found within a single collapse. Variations in the width, height, and speed of the free surface liquid jet, referred to as water spike, with the standoff distance of the bubble were discussed. Okay, so essentially the apparatus is really, really extremely simple. There is a rigid wall down the bottom, which you can raise up and down. You might like to think of this as the base of the Ultra experiment, and or the hard polycarbonate above the aluminium foil. Then there is the free surface here. Now we kind of have a free surface, but we don't. We have something, the aluminium foil, that's able to move to a resonant node. Okay, so this is not similar in that respect. Now, the bubble creator is caused by two wires that cross over, and there is a discharge from a capacitor bank that is discharged through the wire. They have a UV light and a high-speed camera for monitoring what happens. Okay? So, the numerical simulations were mostly focused on the bubble rather than the water spike that keeps evolving for a long time after the bubble rebound. Fewer simulations were focused on the water skirt. In this paper, a number of experiments focused on the free surface motions are carried out over a range of standoff distances. In the above studies, these ones, a second toroidal cavity was observed after jet penetration with larger non-dimensional standoff. Many have successfully simulated the toroidal bubble after jet penetration and splashing. Okay, so I'm not going to read this through all because I haven't read it all through, but it's talking about here, according to the maximum average radius of the bubble is closely related to the duration of the plasma and falls between 11.5 plus or minus 0.6 millimeters when the duration is controlled, blah, blah, blah. Okay, so this produces a plasma in there. Now, the plasma will have positive and negative ions, and it will be HHO, and this itself will self-organize, whether you like it or not. You can, whatever. Now, I haven't read it, so I don't know if they've picked up on this, but I don't think they picked up on it. The experiments were conducted at room temperature, 22 degrees C, and at this temperature, we know that oxygen dissolved in the water or synthesized from the explosions themselves, dissolved in the water, will be paramagnetic, nicely paramagnetic. It will bind and aggregate any clusters that are formed, and this is a basis for the process of cavitation as observed by Sundaresan and Bockris. Now, in this particular experiment here, we have the explosion in the center, and then we have the bubble, okay? And it's coming to the free surface here, and it starts to collapse, and you get a reentrant jet coming in through here that comes through, forming a toroidal bubble structure, and then a breakaway jet torus, okay? So you have two types of torus, and you can see the flow back in there. Okay, so this does produce tori in this instance. This is the single boundary case. Now, this is the frame that I showed on my cover slide. And here we have the case of a bubble approaching a surface, okay? And we have this thin jet coming down, thin jet coming down, thin jet coming down. We also have the water spike, but we have something coming down. And this is very interesting to me because this could imply something that would account for the cone with a pit in it. I'm not sure, but if this is the case, I need to invert the rotation of the bubbles that I drew on my Azizi presentation. It may be the case, but these are known to work both ways, and it might be something to do with where the other boundaries are and where the free surface is. Remember, we don't have technically a water-air interface most of the time in the ultra experiments. Okay, so we have our jet torus coming through here. The interesting thing that is, I don't know whether it's discussed here, but what you can see is a slightly vortical nature here. You can see a slightly vortical nature here, and this banded look here. It's vortical. I don't know whether that's obvious to you, but certainly in the work of Leclerc, he was very keen to show the fact that this was vortical. And you can see here, he's shown the reentrant jet and its helical type structure here. And he goes on to consider, when it's loaded in, that this is actually a water crystal and that it is structured like this. And he thinks that this is something to do with Brown's gas. He says it's a proposed Brown's gas seed. Well, maybe, maybe not. Okay, but it's hexagonal. This is his view. And he comes to this conclusion for a very specific reason. And I haven't got the image together, but he talks about these hexagonal holes here, and then this triangle structure here. Okay. I don't quite know how he's getting the triangle structure, but like definitely the hexagonal I can buy. But we've also seen square holes and so forth. And I think that this is due to a 3 fractal toroidal structure. Okay. And these are due to 6 being around there. Okay. And I will show that on the ultrasonic plate, and I've shown this before, but we actually have this beautiful yin-yang overlaid like this in our classic geometry. In the center of each one, there is a triangle. The only way I can explain that is that it's 2 and the subtor below that. So the overall torus, the N, okay, the N is actually comprised of the 2 n-1 with the n-2 being structured of 3 tori. So it's a hybrid fractal torus. So I will show that in my ICCF 25 presentation. I think David Nagal at one point talks about the different shapes of penetration holes and how it's a bit of a mystery. So I think he did a fairly good job here of considering this thing called a water crystal. but I don't think it adequately explains the triangle and other shaped holes. And in our case, we've actually got this overlaid, as I said, figure of 8, but the actual holes that are burrowed into the steel are triangle holes, which is a little bit weird to think about, but not if they were fixed tori arranged orthogonally to the surface. Okay, so that's going to be a bit of a kicker for the ICCF 20 presentation. Now, what they show here, and when I looked at this, I almost started laughing out loud to myself. We have our toroidal bubble here in this start of this reentrant collapse here, jet, and we have this bit sticking up here. We have the bubble still sticking up with the reentrant jet coming in from here. So with that in hand, I took this image be the image which I used for the cover slide of blowing bubbles here. This image here, I just extended the free surface and the boundary at the bottom out to make my cover slide. And I noticed two things. I noticed that there was a ring here which was dark with a white bit in the middle, and over here there's a kind of a white one. It's not very clear, but just like the free structures in the standing wave in air that I referred to earlier in third-party work here, this one where you have these 2 and 2 and 2 with something going between them, that is what I see in the center of this structure. So I thought, if I lined up my fractal toroidal geometry with this, would we get the boundary condition here? And because we're seeing this at the other aspect to what we were seeing in this work. So this is top down. This is top down, okay? And this would be side on, okay? So I did what I needed to do. And if I move this around, I might be able to get what I need to show you. Okay. So yeah, there is the crumb bubble. And just so I can give credit accurately, this paper is done by A Man Zhang and Pu Cui or Chui, both from Harbin Engineering University. Okay. So Chang bubble at the peak of its spherical radius is that. What I've done is I've rotated it so I've got the reentrant jet coming down. And yeah, so I was actually blown away, to be honest, that it precisely lines up. And what am I lining it up to? Well, I am lining it up to, basically this is a plasma bubble in the center, and you might like to think of it forming similar to, but not the same as, in its self-organization, to something that I showed many moons ago, which is from 1973, the work of Paul Collock, where I believe he was on the right track, and so does the people in the Italian Nuclear Authority, although not quite correct, in their assessment of producing the what do we call it? The not Spheromac. That's what it's the generic name. This is a Plasmac. They called it whatever it is, a Sphero something. In terms of making a fusion reactor. So it's a similar structure to this, but not quite. And that is in the center there. And so if I go in here and I adjust this, you will see it, and then I will turn off the construction lines here, and perhaps you can see that the two cores. You've got a bright core and a dark core here. And the stuff going between them. This is the center of the self-organized plasma structure. And if I turn off the construction lines, the center point here, the center point here, okay, and I turn back on the sacred geometry, okay, and I change the contrast ratio. So the overall main plasma structure is within this main structure here, which, as I showed you before, is the outer part of the bubble, and it's coming in and collapsing here, okay? So I've got those around the right way. I couldn't have wanted a better piece of evidence supporting the fact that when you have the self-organized structure in the center with these two central points of the n-1 tori, they produce this boundary layer over here at this same distance as we observed here in the cavitation structure on the steel. So I am saying, and I've said before, that the material that is taken out of here on the vibration plate, I believe, occurs instantaneously when the structure is resonant and becomes this effectively event horizon. Okay? And the thing is that this is an explosion, and then the self-organized structure that at some point is able to produce the resonant boundary. And it might be the case that this is the mean square radius. If I actually turn on and off the bubble there, it might be easier to see where the mean square radius or the event horizon is. I'm calling it the mean square radius from that paper that discussed the same. So that's not what I want to show. I want to go not to there or either. I want to go here, and I want to turn off the bubble here. So you can see the boundary here of the sphere is exactly in line with the radius of the bubble. Now, the other interesting thing is, if you remember, we have the Sothic triangle. And where is that? Not there. It's over here. Okay. We have the Sothic triangle here. And we have this notch cut out on the Sothic triangle. And if we turn on that part of the sacred geometry, which I've not really shown before, this is the Sothic notch here, and I've just extended it out. This is the same ratio as the Sothic triangle, but just extended out. And I go back to our geometry over here. You can see that the area that comes in and collapses here, forming the neck of the reentrant jet, is in fact the Sothic triangle. Okay, before it becomes a linear vortical beam. Okay, so you have this area that's a certain distance from the edge of the bubble perimeter. Now, it does get slightly distorted, the outer area, but then you have this notch. And the interesting thing is that there is a patented, or certainly a protected, Russian awarded shower head, would you believe it or not, called the Alexev shower. Yes? And it has these same, as I showed you in the patent here. If I go to the patent, I was talking about these very specific, which it makes a lot of in this patent, being very important. Okay? This is a cavitation patent. Okay? And in here it has these conico-cylindrical holes. Well, in the Alexev shower, you have these conico-cylindrical holes, and they go down to 0.6 of a millimeter, and they have a nozzle end that looks like a cavijet. Okay? So you've got a mesh array here a mesh array, and then you have this particular angle here, which kind of goes from the Sussex triangle ratio and then blends out to a tip. Now, because we know this is 0.6 millimeters, it's quite likely that some cunning artist, CAD artist out there, I could do it myself, but there's plenty of you out there that can do this also, could make a 3D model of this, all accurately scaled, based on the fact that we know that the gap here is 0.6 of a millimeter. Now, what do they claim for this award-winning product? Okay, these are the awards. There's the awards. Unique patented design. And this is inventor Alexei Schauer, PhD, MD, receiving the Silver Medal Award from INENA International Exhibition in Nuremberg, Germany. Okay, so here is what it can do. And it's saying that a normal shower with the same pressure, it achieves 10 times the distance here. 10 times so-called stronger. All right. And also it states that down here, the reason is the simple nozzle that looks like any other on the outside is able to give extremely subtle sensations. It has a special effect of the noise of the water and the wind. This means that just like in the case of a waterfall, the water flows at great speed and doing so grabs air ions. Compare 37,000 ions in the air, the maximum that 2 big waterfalls make. 14,000 are produced by the work of Alexei Schauer, and about 2,000 at any other shower. It also has the possibility of physiotherapeutic showers like underwater massage shower, needle shower, and a charcoal shower. Okay, so you can go and have a look at this, but they're saying effectively it produces 7 times the ions captured in the water. Okay? 7 times the ions. Now, if you're capturing ions in water, then that's going to lead to self-organization in the water. So you can kind of understand how cavitation systems produce this kind of charge separation process, but particularly if you've got like the work of Leclerc, you are firing a focused laser into the water to create your cavitation bubble. It produces something of a particular size. One presumes there is plasma in here, like there is in a sea mine, and like there is in this work that we are referring to here by Zhang and Chui. Yeah? Going on, these beautiful images they have in here. So essentially, in my view, you can see it here as well, the plasma in the center with the 2 toroids either side. That completely lines up with the overall structure here, and the re-entrant jet going through this conical cylindrical type effect here. And the other interesting thing is, I'm saying that this is an impenetrable layer, and what you actually see down here is 2 small bubbles collapsing on the impenetrable layer. It's quite surreal. And they don't go anywhere. They hit this layer and it's like hitting a brick wall. And they then end up collapsing in on the bubble and producing ripples on this impenetrable layer, which then spread out on the surface of this layer. So you actually have much more information in these images than it first seems. Again, you have the vortical yin-yang type black-white like barber's pole of toroidal structure coming through here. Okay, it's a beautiful piece of work, really is. Here they've got a thing coming up and a thing coming down, and I'm thinking that maybe this might be something like would produce the yin-yang structures, but I don't know because we haven't got this free surface in our experiments ordinarily. I mocked up this thing which might be possible, where you have the cone and this creates the pit, and then you have the pit and this creates the cone. But I don't think it's accurate because we see our toroidal bubble in the actual home, the like area here. So as I showed you before, so the jury's out on that, but certainly the dynamics are possible. So the bubble, when the music stopped, is literally in this pit with a cone in it. Literally in the pit with a cone in it, okay? So I'm still not sure whether it's my original hypothesis or something else, but certainly the structure that is able to produce this cavitation that I showed you here in this work, I believe is, you can see here on the side. So this is the overall bubble, and in the paper they show that it collapses down like so, and you're starting to get something closer to what was observed by or drawn by Leclerc. Now, in terms of the water spikes, here you've got something where you can see the water spike forming, and it ends up going into this little needle. It's absolutely beautiful right here. So you can imagine something possibly similarly going on, except we in the singing bowls, except we're not getting a plasma bubble and we're not getting an actual bubble. We're just getting the vortex. The vortex is formed in here, but it's not got the buoyancy, as it were. It's just traveling to the surface and breaking through the surface, and then it's not really a reentrant jet. It's the collapse of the energy in the structure, and sometimes it launches itself off and falls off, as we describe with our little smiling faces. Okay, but this is really quite special. So I recommend having a very good look through this paper. In this particular one, they had this skirt forming. Okay. Very nice work, and if they changed the parameters, you ended up by getting the liquid layer breaking rather than forming a jet. And I guess this is the sort of thing that's going on with these ultrasonic misters. You're ending up with the end tip here atomizing and producing these size of water molecules that are able to loft and just become a fog. Okay, so this is kind of what you're probably getting there. Okay, and here you've got like an entrained bubble inside the thing that's lifting up as well. So this is quite fun as well. Okay, so it's a wonderful paper, and they show, as you change the parameters, how the different things occur. So using this, I think that we can enhance effects of cavitation, and with a higher degree of certainty, maybe change the ability of, say, an ultra experiment to do transmutation or whatever by encouraging a particular shape of collapse of the toroidal bubble that is in there, potentially. Okay, so here in this particular one, you can actually see the two wires that form the initial plasma discharges. You can imagine one side is, you know, the cathode, and one is the anode, so the ions are going to be different, and then they come together and they self-organize into a plasmoid structure like in the center, and then this starts a collapse, and then you get this reentrant jet. Of course, this is pushing water here, and it's pushing water here, so that pushes water up like this. It is a little bit weird as this is coming down that's actually pushing up, but like these are the forces involved. Yeah, so there's definitely a vector here and a vector here. And as you can see, the thing is projected down and it's forcing out something behind it. So you can kind of see how the propulsion system would work. But of course, you have to bear in mind that this is dynamics based on the fact that sometimes there is a wall. This is without a bottom wall though. So bear that in mind. Again, here, very, very nice images captured. Really very, very beautiful work that they have done. Okay, evolution of the water spike and skirt along with bubble oscillation with both free surface and rigid bottom. Very, very beautiful work. These are art forms. They're little vases. They're really, really lovely little things. Okay, you almost look like you've got some 3D cymatics going on here at this breakup point here. And here's a very, very big kind of skirt. Okay. Beautiful, beautiful imagery. But for me, the big win was knowing that this is produced with sparks. So we know we've got a plasma like we have in the explosion and like we have in the work of Leclerc. And that in these images, they happen to have captured with enough fidelity that you can see the reentrant jet is going through the plasmoid structure. And when you line up the cores based on the other work, you end up with seeing that the boundary where you are getting the sort of, what I'm saying is it's like a event horizon. It is the same as we observed in the other work that we have done like this. So, of course, this is one explosion. It reaches a optimum shape and then it starts to collapse. That is what is happening here. Okay, so what they're talking about here is in A is corresponding to frames 3 to 5. So they're starting at frame 3. And the bubble's already started to collapse at that point. Okay, so from 1, it's still growing this mean square radius. Okay, and then this is like the peak. Now, in the case of our cavitation bubbles, when you've got a resonant phenomena, you're going to keep energizing this thing. So it maintains this radius. It does grow as it grows, but when it gets to the use of the energy and so on, it appears to get to a boundary. Now, the question I ask myself is this bubble here equivalent to the cancellation zone, of a anapole? By that, what I mean is, if I go back to the presentation from Azizi, when we are talking about an anapole, I'm talking about this. Okay? Is it this boundary layer here where the electromagnetic waves cancel out because you've got the oscillating toroidal moment and the oscillating electric field? Is that the boundary layer and only scalar and vector potentials go out? I don't know. It's something to think about. And could it be that the potentials here, where there is cancellation of the electromagnetic waves, that as that comes out and grows, the boundary layer, that is the thing that disrupts matter? I don't know. These are just things that I am toying with at the moment conceptually. But I think really for me, unless I see evidence to the contrary, I think we've kind of basically nailed it in terms of how these things do what they do. And what you're seeing here is the structure from the side, not by Crum, but by Chang. Is it Chang? Let me just check it's Chang. I definitely want to give the guy credit. It's excellent, excellent work. Zhang, sorry, Zhang and Chui. What you're seeing here is the structure from the side, and here we are from the top. Now, I said this is a spiral that comes in here, the caduceus spiral. It's two parts when you have a fractal 2. You know, you can have any number in here, but it's still going to be 2 if you only have 2 at this level. And so that is why I think you end up with 2 holes in the center here, or 2 spots in the bubble structure, or 2 things in the center of the bar spiral galaxy. Okay? If I haven't made this clear before, the disruption zone here occurs where the subtor Sothic triangle intersects with the n+1 tor above it, and that is the intersection there. That's where the disruption is most. In the case of just a 2 subtor, you end up with it going in a more elliptical sense. If you have 3, it starts to become more like a circle, and then 4, like the wind hex, it becomes much more like a circle. But at 2, it's slightly distorted, and the actual tor would be slightly distorted. Okay. All right. So for me, this is done. This is largely how cavitation works. It shows the magic of how it can bore holes into things, how it can disrupt matter. And in my view, yes, it's doing both left and right torsion, depending on whether you have a yin or a yang structure. And it's able to, this is a very disruptive zone. It's literally pulling stuff apart. So if we compare that to, for instance, here you can see what we're talking about. Not that one, this one, where it's kind of pulling it apart. It's the same thing in this Sothic triangle zone. All right, so I'm going to see if there's any questions before I do a review. A relatively short one tonight. Really, it's in support of the work of Binxuan Huang. And I'll actually, just before I go there, I'll show you a couple of things from his work. So, we're in a kind of little clarification stage with Alexander Parkhomov as to the ways to correctly represent the first equation here, which is the synthesis of 17 oxygen. Of course, the oxygen dissolved in the water is very critical. Sundaresan and Bockris proved that. That is the paramagnetic material. And in this case, you have your exotic vacuum object synthesized, and you have 1H1, and so 1H1 is effectively a proton. If it was 1H0, then, or 1H0, it would be a proton with an electron, okay? But the full expression is a proton plus an electron plus an antineutrino plus 16 oxygen goes to 17 oxygen. In the theory of Alexander Parkhomov, he is saying that the antineutrino here is of cold or relic neutrino or background neutrino velocities, kinetics. So its de Broglie wavelength is microns to millimeters. So it can interact with all of these 3 particles simultaneously. And so that's how it occurs. In my view, potentially, and possibly the view of Shishkin and Dubovik, if he's still with us, and maybe Ken Shoulders, the electrons form a cluster. The cluster can take, for every 10 to the 5 electrons, it can take 1 ion, and the ion will be the proton. So you have all of these electrons in a coherent cluster, and it has a proton, and these are able to cohere relic neutrinos from the environment, and they are able to then grab this as an ion. So then you would need 2 times 10 to the 5, and that would perform in that central core, or in one of the central cores of the subtors, the transmutation to 17 oxygen. This structure is the charge cluster, and that binds to the oxygen. Okay? In the case of how should we put this? In the case of Shishkin, he would argue that the electron cluster itself can form, then it may or may not have ions, but when it disrupts, it produces electrons from the Coulombic explosion of up to 10 kiloelectron volts, and that they collide with other matter and produce neutrinos and antineutrinos. So that is where your low energy, ultra low momentum neutrinos are coming from. And then they are locally available. And so then you are able to produce the reaction with other clusters that are coming in. And so if you had a resonant thing that's there and it's exploding, there it's exploding, then you would, be able to make this work. Now, this is very key what I'm going to share with you right now. And I have talked about it before. But in the hydrowave technology, which was extremely effective remediating waste. In this device, they actually have a system where they have an electrical discharge in the water before it goes into the cavitation area, as I understand it. Okay, I can't remember where it is, but I read that somewhere that it's actually in there. And so by having that in there, you're combining the best of both worlds. You're effectively creating the electron clusters, you're producing oxygen, you're producing maybe free protons. These things can all collide, come together in an exotic vacuum object, a magnetotoroelectrical cluster, and that this can then bind to the oxygen and form the 17 oxygen. Now, since I proposed this to Binjuan Huang, I have learned that these clusters do like to play with spin nuclei. So a proton is spin. Obviously, the electron is spin. This isn't, but these things are binding to O2. Okay? And this process then would occur because they're all in the right proximity, whether you're looking at Parkhomov's theory or the theory of exotic vacuum objects, and that this leads to the 17 oxygen. The 17 oxygen is then spin, and so it gathers up 17 oxygen that's synthesized, and it produces the carbon, which is observed, and the 22 neon, which is observed. Okay? Now, like I said in my original presentation, I kind of misspoke, and here is the reactions. In fact, I got it somewhere else, actually, I think. Let me just get it. Somewhere here. Okay, so in their work, they also observe the formation of phosphorus, and they observe the formation of sulfur, okay, in their work. This is Binjuan Huang's work. This is also predicted from oxygen and oxygen interactions, okay? And 17 and 17 oxygen here can produce protons, and sulfur 33 here, and you've got phosphorus 31 down here from oxygen 16 and oxygen 17, phosphorus 31. But when it comes to the production of neon, my theory as presented in the poster sessions at ICCF 22 in 2019 was that if you're fitting it into a very small box, and I would argue that the toroidal structures are fitting things into a very small box, particularly at the subfractal toroidal levels, you will get the product that produces the most energy, okay? And if we've synthesized oxygen 17 and oxygen 17, we then get produced carbon 12 and neon 22. Because I was reading, because I was sleepy and I didn't do enough preparation, I was reading from the bottom of the table up because that was relevant for the production of 17. How should we put this? If I go to the fusion reactions here and I put in hydrogen and I put in oxygen here, and I put actually A2 equals 16, so that if I see, you can see this is the reaction here. Proton comes in, we have an antineutrino coming in with the electron and the oxygen 16, and this goes to oxygen 17 here. But if I just put this as E2, which is what I did in my presentation a few years ago, and put O and do execute query, you'll see that it's at the bottom of the table, this, whereas if you've got hydrogen and oxygen and going to fluorine, that produces more energy. So I showed this first, and I read from the bottom of the table up, and when I read from this, I also read from the bottom of the table up. And I kind of said, but because like there's a lot of oxygen 16 in there already, then oxygen 17 would most likely form carbon 12 and neon 21. What I didn't realize at that time is that the process likes to capture spin nuclei, of which your 17 is. So if we go to our element data here and we go to oxygen, you'll see that 16 is not spin 18 is not spin, but 17 is spin. Okay, it has spin. So I'm saying it interacts with spin nuclei. So the 16 is not so important. So that's not important. That's not important. And that's not important. So there's two reactions that are important. This one here with 1717, this one here with 1717. And I was reading from the bottom, and I said maybe you're more likely to get yields 6.44411. So in this case, we have oxygen 17 produces carbon 12 and neon 22. Well, you will see in the incredible work that they have done. And so let me have a look at that now. In the incredible work that the team has achieved in the Department of Energy at University of Taipei. Let me see here. What they observe is the production of two non-condensable gases, one CO2 and one neon 22. And it follows the logic. Spin nuclei coming in, forming an electron cluster, which may or may not blow up, producing neutrinos, or the toroidal moment gathers antineutrinos from the environment, binds to the paramagnetic oxygen, synthesizing 17 oxygen. 17 oxygens that are synthesized are then gathered, maybe in the same cluster all simultaneously. Okay, so this process happens almost simultaneously like this, as Kladoff said in his 1993 patent. And this leads to the production of non-spin products. Non-spin product, non-spin product. Okay? And those are then left because they're not easily attracted into the overall structure for further synthesis. Okay? It needs to get pretty mental before that happens. And then you have carbon synthesized, and that binds with the extra oxygen that's been lying around, and you end up with CO2. And so they've actually proven this in some depth. And so in the case of separated the two. Okay? Incredibly thorough work. Really, the whole team should be congratulated. It's fantastic work. So here, they proved that there was no neon 21. Thing that should be synthesized, as I've explained, because of the spin nuclei. And its partner product in the exchange reaction is carbon 12. And in this experiment here, this is tube. Okay. Have we got it now? Dang. That's so annoying. Okay, can someone tell me where I got to before? Oh, this is so annoying. I literally explained the whole thing. Yeah, maybe loose cable. I don't know. Maybe I need a new USB, or maybe I need a new mic. The first graph. Oh no. Okay. All right. When I first pulled up the graph. Okay. All right. Let's look at that. Okay. So what I was describing is that we have spin nuclei, spin, non-spin, but the 16 oxygen as O16O2 is paramagnetic, necessary for Sundareis and Bockris for the iron to be synthesized in their carbon arc underwater. And so since I proposed this, I've seen the importance of spin. So if you, as I described earlier, where we had the 10 yen coin, the copper was shifted over. Where we have the structure on the Henk-Uren cardioid infarction, the metal, the copper is shifted over, and we'll be able to look at that in more detail on Wednesday under the SEM. Okay, so this is spin. 16 is non-spin. It produces a spin isotope. The spin isotope is here. And to clarify, there's only two. I showed that this is spin nuclei is only the 17, and that there's two options. This one, which produces carbon 13 and neon 21. And this is because I was reading from the bottom of the table. I thought that might be the likely one, or because there's more oxygen 16, that might be likely. But I should have been reading from the top. But it turns out that he proved that my theory was correct, not my offer that you would more likely see neon 21 than 22. Anyway, the oxygen 17 produces carbon 12, non-spin, neon 22, non-spin, and the most energy yield. Okay, so what he observed in his in there, and it's a lot of authors that have worked on this, it's excellent work, is that firstly, using all of this equipment, so they have a gas collection here, this gas collector device here that's produced, and they have a mass spectrometer, and they find there's no heavier elements, so it can't be due to subfractions of other elements, and they're taking it from these reactor tubes here. Okay, he then goes to test the hypothesis that there, and I won't go into it, but I will do later when I've spent some time with him. So they looked at the overall, and what they first found is there a presence of neon 21? Absolutely, 021. Okay, which makes sense because 22 should be synthesized over and above, because it is more energetic and it yields non-spin isotopes. Okay, so 21 is not formed. Then they look for the presence of neon 20, and essentially it's not formed. Okay, then they look for the presence of neon 22, and they find for each excess heat reactor they get an overabundance of neon 22. Essentially, it doesn't exist for reactors that had no LENA or broke or whatever. Okay. Then they look for the carbon, which must be the oxygen, and which must be isotope 17 rich, and they do some work on that, and they find in other where is it? Somewhere up here. Is it up here? No, down. Yeah, so they find that there's oxygen O2 rich in oxygen 17 for essentially, except for this one, the heat producing tubes. For carbon dioxide synthesized, they see that there is oxygen 17 rich in the carbon dioxide in the heat producing tubes, and therefore with the preponderance of evidence, it's nearly impossible that all of these different observations would have been made only in the excess heat reactors, or essentially for the most part, other than failed ones and things that did a little bit weird stuff, And so the hypothesis is that O2 with heavy oxygen as one component, CO2 with heavy oxygen as a component, and neon-22 are synthesized. And this follows the theory that is consistent with what should have happened in the process. And yeah, so that is essentially it. So effectively, I think a big round of applause to Bingjuen Huang. Thank you for taking me seriously. And thank you for asking me to be a co-author on this. I really appreciate that. And if this bears out to be true, this is testable, provable, experimental, repeatable data that proves that cavitation produces particular non-condensable gases that are not possible to be contamination, that are commensurate with excess heat. And therefore, cavitation can produce excess heat. And I think, like I say, he's very nervous because it could be a watershed moment. Yes, there's been claims in the past, but there hasn't been a data set that's as robustly analyzed as this. And so, full-on credit to them. Okay, so... right, so I'm going to see if there's any questions. Sorry for the break in the audio. That's just really super annoying, but things happen, doesn't it? So Tony Jaboni said, we've noticed a similar small jet dynamic creating a vorticular vertical column through the wind hex when adjusting top. Yes, you did. And I predict that if the sub-dynamics on there are correct, particularly if you have ionization in there or moisture, you'll end up with the same thing occurring, but at the fractal levels. It won't be so perceived as it is in this because you've got 4 input jets. Yes, D2105K, thank you for joining us. Yes, it is. It's, you know, like I say, he's nervous. You know, but if he cops any flack, then I'll take the hit. I'll take the hit. He can keep his reputation intact because he's been working on this 20 years and they didn't have categorical proof. And thanks to Alexander Parkhomov and to Philip Power and for both working with me to produce those reaction tables, I was able to propose something to him based on what I'd seen already in his data that would be a testable hypothesis. And God darn it, he went and did it with his team. Fantastic work. And he replicated it and replicated it and replicated it and tested with different methods to prove the positive and prove the negative. And also for the other gases, oxygen, CO2, and not only neon, but also the negatives of neon. And the thing about neon is, if you go and look at our the data set here, if I go to look at now, rather than oxygen, I look at neon, okay? Neon 22 here is only 8.82% natural abundance. Almost all of neon is this double magic element, neon 20, okay? So over 91%, nearly 92% of all neon is not neon 22. So to find neon 22 in the absence of the other 2 neons is really rather special. It's very, very strong evidence. So Stephen B. Hall says, I want the drill bit that can drill those Alexeyev showerhead holes into acrylic. Yeah, well, maybe that can be produced. Yeah. I think that is very, very interesting, this head. And certainly there are people, I could do this, but I've got too much to do at the moment. So maybe maybe Tony Jaboni would want to take this on, but I know there's other people that are very good with 3D. And they take this thing on. And as I argue, I believe this structure that they have here This is 0.6 of a millimeter. He defines this. I think the nozzle end is to allow for the cavijet type resonance, and that at some point the main profile here is the Sothic triangle, and it just blends into a tip, so it produces the thing here. Now I imagine that this will feel slightly pulsed. It will be producing these solitons, and it's the solitons that are capturing the extra ions. Well, there is, yeah, I know that for that, but and I did consider that. Someone suggesting saying order the shower head and use compressed air. Someone did suggest that. I did think about that, but the problem is I looked everywhere, and of course with what's going on, and it's probably being sourced from its invention location in Russia. I don't think it's possible for you to get this everywhere I look. So I've got on Amazon here, the same thing on Amazon, and they're all currently unavailable. Don't know when it'll be back in stock. Don't know when it'll be back in stock. So, you know, they're quite pricey actually. So like, it was $114 with $43 postage. So, you know, anyway. Thank you, Curtis Horn. He's saying, Bob, I'm working with Jim Woodward on the Mac Effect drive, and I just recently found your channel. I'd like to explore the effect you described because we are using piezoelectric to create the effect. Let's chat sometime. Absolutely, that would be great. I'm interested in the Mac Effect. I do know that what do you call it? There's a satellite being launched soon on the next Tesla launch, or the next SpaceX rocket to go up soon, I think. And who is it? It's Mike McCulloch's theory. It's going to be tested in a satellite in the coming days. Okay, so 3D, it might be 3D printable, but of course the 3D printable is not so good for something where you've got this smooth flow here. You really want something that, as Stephen has suggested, it is drilled with the correct profile of drill, or it's injection molded, and I would imagine it needs to be fairly sturdy. Okay, so yeah, so maybe someone could, I think because this is effectively producing, in my view, as I say, it's got the right ratio. So as I'm showing here on the reentrant jet, it's kind of the inverse, because the reentrant jet is like, well, yeah, it is water coming through. So when I'm showing the here in Photoshop, when I'm showing this Sothic triangle start of the reentrant jet going into a tube, and then the opening out, this is essentially, I have to think that he knows that this is correct. The geometry is precise, and you can't make it any better. You can have an opinion on something that might look better, but it's not going to be any better. What he probably has done here is design this based on the reentrant jet that forms on a collapsing cavitation bubble. And as a result, nature resists it the absolute least, and it probably goes into a vortical structure as it goes through. And with the pulsations that may occur, I expect if it's got a cavijet type resonance going on, then it will produce these toroids, and that's why probably the flow is 10 times stronger, because there's less resistance going through the ports as it works. Half water consumption. Conoid holes, that's what it calls, and I think that's exactly what it says in this pattern. Actually, if I go back here, I think it says conoid holes. Let's have a look. Conoid. There we go. There we go. The problem is solved in that the thermal cavitation generator, consisting of a rotor formed by sequential installation of centrifugal and cavitation wheels, half-open type guide vanes with a spatula grill housing with a return vanes diffuser, suction and discharge covers, brackets with support units, cavitation wheels, are made in the form of a disc perforated with conoid cylindrical nozzles, with radial blades. So there, conoid cylindrical nozzles, and that is what you're seeing here in my view, conoid cylindrical nozzles, and I believe that is based on this, this structure that we see coming out of nature. And you can have all the opinions in the world, as I say before, but you're not going to make it better. Yeah, so I think you can have a go at making this, and it would be interesting to see, like, on exactly the same pressure from your home water, what different people's attempts to make this, how much more jets they will form, and if the claims are true. If the claims are true that they are producing 7 times their number of ions, where is it? 7 times the number of ions that you get out of a normal shower. That is that good for you? Maybe. So thank you, DIY with Projects with Chalksis, for your super chat. That's really wonderful. Thank you. Yeah, don't forget the chamfered edges. Yeah, that's part of being the cavijet. So the chamfered edges are on the bottom, right? But like I say, you don't need the designs for this, because he's already told you that the cylindrical hole is 0.6 of a millimeter. So from this photo alone, you can reverse engineer exactly what you need. And you know that it is correct. And he knew that this was correct when he made it. I don't know what the patent number is for the shower head. I didn't even bother looking for it, because I immediately saw that this is a conoid cylindrical hole, and it has this reentrant jet type shape. It is this. If I remove it's this shape here. Okay. So it's playing for some reason. I don't want it playing. I just want it staying. As ever, Space Case, I will share all of the patents and the things discussed today tomorrow as part of filling out the blog on remoteview.icu. And if anyone can dig out the original clad-off patents, that would be fantastic. Yeah, there are actual drill bit grinding tools that you might be able to create a profile like this. Or I might be able to use a particular technology that I witnessed in that I will be testing samples from on Wednesday, which may actually support the work of Matsumoto. Yeah, you might be actually able to just on a CNC lathe produce a drill bit sufficiently good enough to be able to bore into something, if you chose the right material. So Exotic Propulsion saying, in a matter of speaking, the shape of the cone is all about impedance matching the jet pressure to the working medium. Yeah, probably. But the answer is already in that image. You don't need to invent this again. And yeah, you just don't need to invent it again. The job is done. Okay, just going to go up and see if there's any questions. Yeah, if someone can find the patent and send it over to me for the patent number for the shower head, that would be great. Of course, it may not actually even be patented. For me, what you see on the screen with the top-down view of the fractal toroidal basic two-tor structure that I derived only by looking at experimental data and realizing that this is the same thing as the bubble structure, and it is the same thing as the bar spiral galaxy. So it works on every level. Finding this paper this week, I have to thank again Charles for just nudging me with something that made me think about things slightly differently, to ask the right question and find this work. Of course, the work references many other things that might be good to look into, and if people have got time, that would be great if they could do that. But I think we've answered the main question. Self-organized plasma in the center produces the toroidal structure. It has this boundary that is the boundary that you see on the right, in my view, that cut out the hemispherical section from the steel in the Amasa vibrator plate. And yeah, and maybe, just possibly, something similar is going on with the yin-yang structures, but I'm not totally convinced about that. Okay, so Curtis said, send an email, can't chat here until 3 hours subscribed. Yes, I'm sorry about that, but there was a number of people that came in and they were asking or just trying to disrupt conversation, so, but thank you. So join the technicians. I said, can you take a call after? Honestly, I'd love to, but like, I'm all day session on Wednesday on the SEM, and I'll back late. I'm acting on Tuesday to earn a few extra pennies, and tomorrow I'm going to be recovering from this, writing the blog and finishing my amendments and comments to Bin Juan Huang et al.'s paper, to feel that, other than suggesting the way forward, that I actually made sure that, to the best of my ability, it makes sense and is consistent. Yeah, so I kind of have to do that, and then I actually have to do my own presentation, which has to be uploaded by a certain date, and I'd actually like to submit a paper this year, actually the paper, because in my view, we're kind of bringing all of these different aspects of different technologies together. You know, it's not necessarily going to be easy to deliver any of these technologies, but if you want to blow a ship up, you can do it. And if you want to have a powerful shower, you can do it. And it's all using the same principle. I don't even know if they discuss the substructure of the self-organized plasma ball in the center of this bubble from their electrical explosion underwater. But it doesn't matter, because they shared the work. And so, therefore, they might be effectively analyzing how to make a better sea mine, and rather an innocuous paper. But from my point of view, they gave me the answer that I needed to see this from the other aspect. And so, thank you. Hey Bob, I've been mapping many different aspects of this vortex coil system I'm working with. When complete, can I send you all my data? Of course, yes, absolutely. I can't guarantee I'll make sense of it, but I'll try. Ken Pratt says, I'm not really trying to disrupt the conversations, really. Okay. So, Riandathor is saying the water is some kind of electrogel. I think it's charged water. Or that it is creating ions in the air. So, like, it would be interesting to see if you had one of these cavijet conoidal tubular type heads on your garden sprayer, if you ended up with your plants growing better. Like, he sees this for some sort of massage therapy, revitalizing, powerful, efficient jet. When I look at it, I say, can I make my plants grow faster? That's what I see. It's like electroculture without the electricity. It's just using the power that's coming from the mains to create toroidal cavitation, and plus with the water pressure you have, you can spray it a further distance. So, like, I just don't want to cut holes in the leaves of my plants. So, Crypto Alcon says, hey Bob, don't forget that I need you for 100 more Real Science episodes to record. Okay. I'll still be around after I've done the Shijin conference. Oh, and on that note, I might be going to the Bosnian Pyramid in September, early September, with the founder, and hopefully be able to go into the off-limits area and see any artifacts that have been recovered. So things are definitely moving in the right direction, let's put it like that. Yeah, so that's what I'm saying. Make a watering can with that shower head. Yeah, that's essentially it. And then does it... Tammy, you're criticizing my garden technique. Say hi to the pyramid. I'll do my best. Let's see if it speaks back. Oh, of course, Kay. I will record everything. Take a whip along. And a leather hat. Attached to a pressure washer. Yeah, you could probably attach these things maybe with less holes in it and end up with even more intense pressure. As I showed you with the Cavijet patent, I think they were able to with the same input water pressure, they were able to burrow through rock something like 4 times faster with the Cavijet, and it's the same pressure, but it's basically almost creating a resonant water hammer. But the thing that's coming out is not just a rarefaction pulse; it's actually a toroidal structure that carries the energy forward. So it's efficiently going through. It's building up energy and releasing it. And it's releasing it in a toroidal form that carries through and does more damage to the material. So I think you could make a vastly more efficient pressure washer. So you might be able to make a pressure washer where your actual impeller, the thing driving the pressure from the mains, or you might even just be able to make a pressure washer out of the standard mains pressure, like 3 bar, right? By judicious use of this. There's lots of opportunities now, and you won't be able to make it any better. Once you get the right angle of this thing, once you literally have this at the right angle, and I believe that it is based on what nature does as the most efficient form for the re-entrant jet, you will not be able to improve it. Crypto Alchemist, and take me with you to the Bosnian pyramids, at least through the camera. I will do. Yes, I'm going with Yin Gazda, and I will be going with the European representative of the Bosnian pyramid, Birgit, who I met at the conference in France. And so... yeah, I mean, of course, the vortex will be important, but I'm not sure Schauberger did work on the reentrant jet. I think that was something that was discovered later. That being said, obviously they had this conicoid vortical structure going on, and the forces that involved are similar. So yeah, I mean, it would be great. You know, I think this would be a relatively easy thing to make. Maybe direct laser metal sintering. You would be able to have 1 micron perfections, and then you might be able to create a device to polish out the structures here. Yeah, I mean, there's various ways to produce it, but ideally you just want to injection mold this part, and then you can just knock it out, knock it out, knock it out. Okay, so I'm just going to do a quick review of what we talked about today. But for me, this is a special moment in cavitation because I think we are potentially on the verge of having 100% proof of cavitation producing non-condensable, non-impurity elements in non-natural ratio isotopes, which are predicted by the process to have occurred, given the starting parameters, in commensurate with excess heat in multiple sequential experiments. And where experiments did not produce excess heat, you do not observe the excess carbon, the oxygen-17 synthesis, and the neon-22. And so the likelihood of all of these things being there when it is the most likely outcome of the proposed reactions is very, very, very slim on the negative. I think this is positively showing that we can prove cavitation produces excess heat, and then you're off to the races. I think you know that there'll be a lot of hard looks taken at various cavitation technologies, and particularly with the these ones that are sold, these very simple devices that are sold in former Soviet countries, Ukraine and Russia and Belarus and things. These devices that produce, say, around about a COP of 1.5. You know, you're not having to have a refrigerant in there. It's mostly effectively solid state. And rather than using a electric heater, you're getting, which produces up to 1 from your electrical energy in, you're getting thermal energy of around about 1.5 out from your 1 electrical energy in. That is awesome. I have no idea how long it's going to take before you get that kind of performance out of a tokamak. Can you make it better? Maybe. I think that if you have a closed loop and you introduce certain chemicals, you will be able to heighten the excess produced, and then you have a heat exchanger. Or if it's in a radiator loop, it may not matter anyway. And you just have the closed loop of the water. If you're synthesizing gases, then you will need to have some form of means of bleed off so that you don't have the pressure collapses. In the work of Binxuan Huang, I have one reservation that the collapsed pipes may not only be due to pressure, but they may also be due to the action of the clusters on the copper, the lowering of its rigidity, so that when there is pressure there, it's more able to be deformed. Okay, right. So this was O'Day blowing bubbles. And on the right, we have our reentrant jet from a plasma-induced cavitation bubble. And we have some small ones colliding the event horizon on the outside here and themselves collapsing into it. And so this, for me, solved a long-standing issue that I had to resolve with how I do the completion of the other axis, having established that across various scales of material and various experiments by various independent authors, this structure reappears both in nature and is a basis for how much of nature works right the way up to the scale of galaxies. And that given the case, this fractal toroidal structure, could we see something at the other orientation? And thanks to Charles for sending me what I showed you here on the Wikipedia, I came to discover the fact of the bubble jet effect, which you can see here in a detonation of a naval mine. Okay. So this led me to find this paper by Zhang and Cui, and their excellent work, which should be highly replicatable, with their little plasma toroids in the center here, leading to these reentrant jets, and this beautiful image with these impacting ones on the surface, and these water spikes and water needles and water skirts and misting type effects going on. And cavitation in general is something that has been shown to do transmutation, and I discussed it in my Azizi presentation last year in Ultra, a simple and quick and repeatable demonstration of the Lena process. And I showed that you do get these toroidal bubbles when the music stops, and they lift off, but they're doing all kinds of dynamic things in the interim. They do produce the yin-yang, they do produce the sacred geometry. This is actually Bin Zhuan Huang's work on copper in ultrasonics. And again, he saw the sparse spiral galaxy structure formed, and extra carbon and oxygen being deposited in this area. And I spoke about how in this sound field here with the standing waves, you got these separation of two spots with stuff going in between them, and that allowed me to see what was meant to be going on in the explosion underwater reentrant jet type work. And so building on Kladev's work, where he was able to cause or state that there was changing the structure of nuclei by adding one or more structural elements. In the case of forming 17 oxygen, we have added an antineutrino and an electron to a proton, and then we've added that to oxygen 16 to produce oxygen 17, and then changing the structure of a nuclide by dividing into several fragments. Right, well, we've first in the second reaction, we are effectively fusing 17 oxygen and 17 oxygen, and then that is dividing, producing 12 carbon and 22 neon. And so we are basically again doing the first thing and then separating here. So this is not fusion in the traditional sense. This is multi-particle interaction. And then it is fusion and fission, a bit like the first reaction by Cockcroft and Walton, where they fired a proton into lithium-7. It fused to make beryllium-8, which almost immediately decays to 2,4 helium. So it does those two, and then you have changing the structure of the nuclide by dividing into the smallest structural fragments, or by the complete transformation of matter into radiation, into field forms of existence of matter. I believe that that is what you are seeing when you are looking at the hole that is being generated in this cavitation here. That is due to the conversion of that matter into field forms of matter, or actually maybe into other elements, and it's been taken away by the overall fractal toroidal structure influence. Okay, so and that this went on in his later work to do remediation, so we know that it has to have neutrinos involved, or most likely, and then if you keep doing cavitation, you end up with producing more and more elements. And this was also what Leclerc observed, what Dr. Roy Shinamaza observed in his vibrators, and so forth. So and other people like Stringham and Roger Stringham and Thomas Claytor. So all of these people have observed these transmutations in cavitation systems. And he specifically says supermicroscopic black holes, and that they produce some electromagnetic radiation when they are operating. Okay, and there's lots of magic numbers which are non-spin elements. Okay. So that being said, I went on to show how this was also observed by where is it? Where is it? Let me find it. By Leclerc, and what I will share at ICCF 25 is, in my view, the explanation for why you can get these geometric marks produced by cavitation. It may be this in at least some instances, but I think it's actually because of the sub-torus involved, and I think this would be just a torus which is of 3 tori, and I will show this by a yin-yang structure on the Amasa vibrator plate, which in the center of the n-1 tor, there's an n-3 triple structure with two exactly the same triangular holes on either of the center of the two main tor level. So there we go. And I think that's basically it, really. I said there was some relationship with the 1973 work of Paul Collock, and I talked about Crum, and then we went on and talked a lot about how this is essentially a manifestation of the most efficient way to get water through, and end up by producing toruses as it comes out the other side. So there we go. I think that's basically it. Thank you very much for your time. If you've got any other questions, that'd be great to hear them. Maybe I'll have a shave before you see me next. So what happened to the collapsed pipes? Well, he keeps them. It's part of the evidence. So like on the collapsed pipes, you can see the phosphorus, the carbon, the oxygen, and the sulfur that's being produced. So those are persistent evidence. The gas, you know, that's different, but like having a single isotope of say neon, and it being the second rarest isotope without the other isotopes present. That's pretty good evidence, in my opinion, over and above the presence of CO2 with oxygen 17 rich and oxygen with 17 rich. It's a pleasure, WP for the truth. So KB says this may have played a part in Walter Russell's transmutation processes. I personally believe all transmutation processes will use this sacred geometry, whether it is the fractal sacred geometry in water, as sound vibrations in material, coherent matter, in a plasma, or in the ether itself. It really doesn't matter. It is, in my view, until I see something that, you know, completely blows it out of the water. I think the ancient people knew it. I don't know how they knew it, but they knew it. It's in all of their work. And we're just rediscovering it. We're de-stupidifying ourselves. So Harry says, what exactly was the experiment Zhang did? It's exploding. It's exploding or discharging underwater. Here. So, very simply, to go over it again, you have a blacklight, a high-speed camera. You have a rigid wall, which you move up and down. An electrode here with two, you know, a positive and negative thing. You have two distance parameters here. And you have the free surface of water. So you can see in the charts what causes what. And from that, we should be able to optimize what you get out of a particular bubble when you conduct it, an experiment. So they have a 200-volt DC input, 6,600 microfarad capacitor, and they charge it, and then they discharge it through the thing in the water. That produces oxyhydrogen plasma, which self-organizes, and you can see here, that's the plasma. It collapses into a self-organized torus, and that then starts pulling a reentrant jet through, which has a vortical nature to it, and hence many of the things we observe in our work. And it produces toroidal structures and so on. And also later, depending on changing the parameters, you can get a really nice water spike or water needle effect going on. You see here, it's a very, very, very consistent profile here for this ejection. And that is, in my view, because in here, you've got a torus here. And that is forcing the water through our conoid cylindrical structure, through the center here, and producing this jet. And that, my friends, is, in my view, what is going on in this device, which accounts for the 10 times stronger solid jets using half water consumption. Okay? So in theory, you should be able to tune the cone to generate the periodic table. No, the periodic table comes from what you start with and how long you process it for, particularly in resonance. And when you are producing reactions, depending on what you start with and where your resonance is and the energy in there, every time you stop the process, you will have a range of elements. So that is what you are seeing when Kladoff is saying you start with whatever elements in like water and whatever the vibrator is made of, and over a period of time the elements get broken and made and broken and made, And so you then have new elements as your starting elements that then can mix together and produce, tertiary, quaternary, and so on mixtures. And so you progressively get more. And so this is why I'm saying your thermal spring water that's been going through little cavities underground at high temperature and pressure and producing all kinds of cavities as it's going through different channels. This is mineral rich. And I've argued in the past that that is not necessarily because it's dissolved minerals from the rock. It's literally synthesized the minerals. And that's why they're so bioavailable. And the ancient people knew this. That's why they cited many of their favorite places to live right next to thermal springs. Yes, Daniel Foster. I'm sure you don't want to do that. So Anthony Williams is talking about Leclerc's work. So that's exactly what Leclerc did. So if I go, where is it? Where is it? Here. Leclerc actually used, and this is highly dangerous, he nearly killed himself. So you've got a basic pull pump here, and you have an increase in pressure and a drop in pressure. So this is basically what's going on in any of these cavitation systems, and it goes through this rolled up Swiss roll of standard sheet, aluminium sheet, and as it's going through here, it's got loads of different scale torus holes, cylindrical holes, or round holes, and of course that will lead to the form of the formation of toro. So Terranart is saying, I wonder if archerfish make use of toroids like blowing smoke rings. Probably, certainly. Yeah, so Moribi King, and I will be talking about something he said about Ken Shoulder's work in my ICCF presentation. Hey Bob, so streams under the right condition, you could grow elements naturally, sort of. Yes, yeah, that's what I'm saying. And I've said that. You can go and look at my ICCF 22 2019 poster session, and I talk about that. Ken, you probably will do, yes. Yeah, pistol shrimp as well. Yeah, I mean, that's a shockwave, but even a rarefaction pulse that will be caused by a shock, by a pistol shrimp, at least, even just a rarefaction pulse is kind of slightly toroidal in its nature. Okay, so please, if you've got any other questions, ask them on remoteview.icu. This has been a real pleasure to me, in my opinion, to share with you a resolution from the other aspect of the fractal toroidal geometry and the possibly the mean square radius, but definitely the event horizon of these structures. Of course, in here, the plasma is formed, it reaches its limit, and then it collapses. In the case of resonant cavitation, like the ultra experiment, it continues to produce or feed the energy to the resonant nodes. And so the process is accretive, and this is why sound can be extremely dangerous in terms of producing up to potentially very heavy elements very quickly. So that's why I like the ultra experiment, because the aluminium or copper or whatever you're using as your base material, you have a thin sheet, and so it will fail after a period of time, and so you don't get too heavy. And I'm not recommending people do that. Otherwise, you might suffer the fate of Sergei and Mark Leclerc in their pursuit of this, which nearly killed them both. Okay, so my name is Bob Greenyer, and this was Ode blowing bubbles. Good night. Dobranoc. Buenas noches. Buenas será. See you soon.